I'm going to find the inverse Laplace transform of f of s, which is equals to 10s divided by s squared plus 10. And then for the second one, we are having f of s is equals to 12 divided by s squared plus 4s plus 20. So I'll start by looking at the first one there. To find this inverse Laplace transform, I am going to use the table of Laplace transforms. So what we do is we look for an f of s which is similar to the one that is given. If there is none, then we try to rewrite that function there. So in this case, we see that there is no function which is similar to the one that is given. But we see that our function is almost closer to this one here. So what we would have to do is we have to introduce an a squared. So we can try to rewrite our f of s, which is 10s divided by s squared plus 2. But in this formula, we just have an s, so we'd have to factor out the 10 there. So when you factor out the 10, then write this 2 as a square, we would have 10 multiplied by s and divided by s squared plus the square root of 2 squared. So the function that we have here is now similar to the one that we have in the table there. So by comparison, we see that a is equals to square root of 2. So we can substitute a equals to square root of 2 in the column for our f of t here, and then we would have that our f of t is equals to cosine of t multiplied by square root of 2. So that is our f of t there is 10 cosine t multiplied by square root of 2. So that's the f of t for the given f of s. So what we are saying there is the inverse Laplace transform of 10s divided by s squared plus 2 is equals to 10 multiplied by cosine of t multiplied by the square root of 2. So that's the inverse Laplace transform that we have there. We then move on to the next question, where we are having f of s is equals to 12 divided by s squared plus 4s plus 20. For this f of s, we see that in the table of Laplace transforms, we do not have a denominator which is of the given form here. And usually we can try to factorize, but in this case we see that we cannot factorize this denominator. And if we cannot factorize the denominator, we have to simplify by completing the square. So for completing the square, if we have s squared plus bs plus c, it will be s plus b over 2 squared minus b over 2 squared, then plus c. So we apply completing the square on the denominator there, and it will give us 12 divided by s plus 4 over 2 squared minus 4 over 2 squared plus 20. And that will simplify to 12 divided by s plus 2 squared, then plus 16. Also, in our table of Laplace transforms, the other term should be squared. So we can just try to write this 16 as a square there, and then factor out a 3, which is common. So that would have 3, then times 4, then divided by s minus 2 squared, then plus 4 squared. So that is the expression that we are having now. And we can then try to find that expression in our table of Laplace transforms. So we are looking for this expression here. So we were guided by the table in coming up with this expression. We were trying to write it in a form which we can find in the table, of which in this case we can see now it is of this form there, a b, then a b squared, then s minus a. So by comparison of the two highlighted parts there, we see that our a is equals to minus 2 and our b is equals to 4. Then we go on and substitute into the column for f of t, and then we have our f of t is equals to exponent of minus 2t multiplied by sine of 4t. So that's our f of t there. We go on and substitute it into the highlighted part there. Then we have 3 multiplied by exponent of minus 2t multiplied by sine of 4t. So for that given f of s, that is the f of t. So what we are saying there is the inverse Laplace transform of 12 divided by s squared plus 4s plus 20 is 3 multiplied by exponent of minus 2t multiplied by sine of 4t. So that's our solution there.